Hello everyone, a warm good afternoon and a welcome to all the participants, resource person and the advisors team of Thickness Learning Community. We, Thickness Learning Community, are happy to have you here for the international webinar on integration of image processing and artificial intelligence for intelligent system development. We, Thickness Learning Community, is a new online startup zeroing in on sharing the knowledge through collaborative studies by organizing expertise and professional talk, inspiring and motivating young minds towards entrepreneurial leadership vision through various programs and accelerating women empowerment that could commit to scale up the quality of their life. Our upcoming webinars are PCB designing, cybersecurity, IoT, and etc. And now I would like to introduce a dynamic resource person, Dr. Noor Adishi Math Isha. Dr. Noor Adishi Math Isha received his Bachelor Engineering degree in Electrical and Electronic Engineering with first class honors from Universiti Sains, Malaysia, USM, in 1999. In 2003, he went on to receive his PhD degree in Electronics Engineering, majoring in Image Processing and Artificial Neural Network. He is currently a professor and the Deputy Dean, Academic, Career and International at the School of Electrical and Electronics Engineering, USM. His research intents includes intelligent systems, image processing, neural network, biomedical engineering, intelligent diagnosis system, and algorithms. As of now, he has led his Imaging and Intelligent System Research Team (ISRT) research group to publish at both national and international arena. He has published more than 150 manuscripts indexed in ISI out of a total of more than 250 publications. Due to his outstanding achievement in research, he gained recognition both national and international. Some of his achievements are appointed as visiting professor, keynote speakers, external examiner for undergraduate and postgraduate programs, examiner and assessor for thesis and research grant and editorial board for international journals. In addition, he has successfully graduated 25 PhD, 24 Masters Research Mode, and 16 Masters Mixed Mode students. With this note, once again, I would like to welcome a resource person and all the members of Thickness Learning community to this international webinar. Over to the resource person. அதை செக் பண்ணுறது ஓப்பன் பண்ணுறேன், ஓப்பன் பண்ண முடியல, ஓப்பன் பண்ண முடியல. ஃபோனில் ஃபேஸ்புக் ஓப்பன் பண்ண முடியல, திக்னஸ்லேயே ஓப்பன் பண்ணாதீங்களா, வேறு எதுலேயே ஓப்பன் பண்ணுங்க. இப்போ உங்கள் வீட்டு ஃபேஸ்புக் ஓப்பன் முடியாங்களா?
இதுதானே அது என் அக்கௌண்ட்டில் தான் இருக்கிறாங்க. இது என்னோட அக்கௌண்ட்டில் தான் இருக்கேன். இது போக முடியுது இல்லை, அம்மாவுக்கு வருது,
அவளோட ஃபோன் கேட்க முடியும். இப்போ என்ன பண்ணுறது? என்ன பிரச்சனை கூட நமக்கு தெரியாது. அதில்
பண்ணலாம்.
கிளிக் பண்ணுற சத்தம்லாம் கேட்குதாண்ணா? இந்த கதவை சாத்துங்க. இல்லை இங்கே எடுத்துருக்கோம். இந்த கதவை சாத்துங்க. நீங்கள் வெளியே போயிருங்க. லாக் பண்ணிடுங்க. வெளியே லாக் பண்ணிடுங்க.
So meaning that whatever that we think about the capability of the machine or the robots, basically, at the end of the day, human is actually the best one of the decision maker as compared to human and also robots. So that's why when we are developing an intelligent system, we are not trying to replace 100% the human workload or the human task. Because what we want to do is we just want to make sure that the machine and the humans, they can work together. Because every aspect of the machine, the beauty of the machine and the beauty of the human, actually they need to be combined together, need to be integrated together. Because by having, okay, for example, let's say if we have the human have what we call the empirical, what we call a characteristic, while the machine have the explicit, what we call machine. So humans, they have the experience, they can respond to the new environments, they can adapt to a new environments, while machine can have a better or more objective decision. Because if you refer to humans, sometimes, okay, let's say I give you the example when we have the situation where there are two doctors want to what we call came out with final what we call final diagnosis on one patient. So maybe there will be what we call different thought by these two individual what we call doctors. So this is what we call the empirical, because maybe Dr. A has more experience as compared to Dr. B. Well, Dr. B can respond to a new what we call a situation, and he knows about, or he or she knows about the patient's social life or whatever. So this is, we come at the end of the day, there will be a two contradict diagnosis between these two doctors. So now we need another thing, which is machines. So machine will what we call give the opinion in terms of the more explicit decisions. So by having this explicit decision, so these two doctors can whatever can integrate their results with the results produced by the machine, and the other day they can come up with what we call the one final decision. So the decision by the machine is actually want to support whatever and give maybe the second opinion to the doctors in order for them to look back about the diagnosis result and so on. So basically, as I mentioned to you, the machine is not to replace the human, but they are only to support and provide the second opinion to humans. So second opinion means that it can only, okay, this is based on the machine, based on the algorithms that put inside the computer, whatever, see, this should be the results. So now this result can be used by a doctor in order to what we call justify further either this decision done by what we call the machine or the system is okay or not. So that's why we say that is give the second opinions to human or to expert in order to come up with a final decision. And once again, the final decision are still in the human hands. So basically, this is actually more critical if we refer to the medical application, where the medical application is about the human life, you know. So we cannot 100% what we call leave to the definition. So at the end of the day, whatever this is the final decision. Extra opinions for the doctor to do what we call the final decision and so on. So there are many development of intelligent system for, which is the first one is try to integrate between, the first area is artificial intelligence, and the second one is image processing. So when we talk about the image processing, essentially we play with images. Okay, we play with the images, and based on those images, so machine will use sort of the computer intelligence, such as we have logics or whatever, in order to classify the image, or we do something to the image. Either we want to extract what you call the features, the information, the important features from the image or not. Then after that, do the decision. Either it can be, is there any, for example, if we refer to the defect detection, is there any defect or not? And if there is a defect, where are the defects and how how big is the defect and so on, where are the location and so on. So if we refer to the medical imaging, so when we have the image from the doctors or whatever, so the image processing will extract all those important features from that medical images, and based on the extracted features, so our artificial intelligence, for example, GA, whatever, then do the decision either the patient have the disease or not. So that's what we try to what we call to develop in our intelligence system. So we just our scope is only boundary by the image processing and also artificial intelligence. Okay. So basically, what is artificial intelligence? Intelligence is actually we try to simulate the human intelligence, and then we try to imitate whatever how I think most of us know that we try to imitate how the human think and how do human make a decision. So they make a decision by their experience where they learn at the school. For example, we take a doctor, for example. When a doctor wants to be he or she have to learn in a medical school. So there he or she will what we call obtain and take all of what we call absorb all the information that give to her to him during the what we call the period, and then after that when he or she works, then he will apply whatever the knowledge and also the experience during his study, whatever, and he do the decision. This is similar to our machine. We try to have the similar process where we want first we need to train the machine in order to exactly know about whatever the decision have to be made. So it's similar. We have a data. We need to train data. So this kind of data, should be the result. This is if it is this kind of data, so this is should be the result. Then we train the neural to become make sure it pass a certain level or whatever. When the machine pass, then we can now include or provide the new data. When we provide new data, now the machine is actually, we call it intelligent enough in order to do the decision or to make a decision. Okay, so this is what artificial intelligence is all about. We try to imitate the human intelligence, and we try to think about the human, and we try to mimic their actions. So based on the thinking process or whatever, so at the end of the day, we try to do the decision, the final decision on whatever the data is given to us, okay, to the machine. Then now, as I mentioned to you, the first part of my we call image processing is actually a method to perform operation to the image. So the operation is actually we try to imitate how we visually what we call look at the image. So for example, when you are given an image as humans, what are the processes and the activities involved when you see the what we call the images. For example, let's say you have the technician or the engineers looking in one microscopic what we call electronic equipment to detect whatever the defect on that equipment the equipment images. Then what he or she does for the first time is he or she will what we call observe. Is there it is a good image or is it not a what we call a bad image? It is a good image, meaning that is the contrast is there, the quality is there, there is no noise or whatever. So let's say there is a noise, there is the contrast, there is noise. So your eyes will try to what we call to try to eliminate. Okay, try to eliminate all those unwanted regions. So you what we call that your eye will have its own capability in order to know, okay, this area there is a what we call the noise there, the unwanted artifact there. So this is the background. Okay, this part is actually what we call the region of interest, the region that we need to what we call focus more, because there are what we call there are the regions that maybe the defect is occurred and so on. So that's what happened to your eyes visually when you look at the image. So we try to imitate the same activity, the same task by the what we call the humans. So what we need to do is we need to, when we when the images are given to the machine or given to the robot, so the machine needs to make sure, first of all, need to analyze the characteristic of the image. The characteristic meaning that about the quality, about the contrast, about the and then is there any noises or whatever. If there is any noises and the quality is not good, the contrast is not good, so the machine have to do the same. So to do the same meaning that, okay, try to improve the contrast and then try to eliminate what we call the regions that are refer to the what we call unwanted regions or unwanted noises and so on. So after that, focus on either what we call the region of interest, that the region that we want to focus more. So we try to use the same. So when you do the what we call the research in image processing, so first of all, when you are given an image, whatever it is, so you need to how do you use your eyes in order to process the what you call the image. So the same when the same process must be transformed into what we call the algorithm in the system or in the computer. So that's why how do we do we can provide a good image processing in order to process the what we call process the image. So whatever it is, you have to trust your eyes, trust your visual. How do you see and how you visualize the images? And the same process, try to imitate and try to implement it in terms of what we call the serial codes and also the algorithms, and apply it in your machine or system. So that's how we do the image processing research. Okay, so now by integrating these two, the image processing and also artificial intelligence, so we try to imitate, as I mentioned to you, how the human visual system works. So how do you see the image? So what have to be done to the image visually? When you get the image, what have you be done? So we want to do the same process. We need to implement the same process in a computer, in the system. So similar to the what we call to performing the decision. So when a doctor when a doctor are given, for example, when a doctor are given the image of the cell, for example, so he or she wants to what we call decide either the cell is a normal cell or is abnormal cell. Abnormal cell. So there are features need to be extracted by the doctors, right? So doctor will check, okay, maybe your cell is not what we call has been is big enough, is bigger than the original one or whatever. So you need to make sure that the same what we call features extracted by the doctors or whatever the expert is, and then based on the all the features, we use then what we call the brain or whatever to do the decision. So meaning that when you are going to have the image processing, in order to extract the features from the image, so you must refer to the expert. What are the what we call the features that extracted by the expert in order to make a decision? So in the image processing part, you need to do the same. You need to extract the same features, because we want to use the system. The end user of the system is the people that need the system. For example, the doctors, the engineers, whatever. So you need to fulfill their what we call their request, their requirement. So what are the features that are used? So you have to use the same. So you need to accept the same features. So how do you want to accept? So that's why we're going to use the image processing. And after that, as I mentioned to you, we have sort of the brain, how the brain works. So you need to develop a system that can imitate or can imitate the brain, but in artificial brain. Okay, so we have the biology brain. So we try to have the what we call the mathematical model or whatever to imitate the what we call the biological brain. So we call it the artificial brain. So we try to combine them together, and at the end of the day, when the system is given any image, so the system can do the decision, can what we call can perform from the what we call image processing until the decision, okay, the final decision. Okay, so this is the major components of the artificial intelligence. So this is actually the what we call the stages that involved in our research. So they might be different stages as compared to others researcher whatever. So in my team, we have these four major components in our intelligence system. So we need to focus on these four processes or these four stages. The first one is for sure is data acquisition. Data acquisition is we try to have the what kind of data you need. If you want to need the X-ray images, or you want to have the microscopic images, or you want to have the ultrasound images, or you want to find what we call the normal images that you capture using your phone or whatever. Okay, so after you have the data, whatever it is, so you must make sure that the data must be stored in the system. So you need to convert the data, whatever the image is given to you, you must convert it into a digital image. Okay, because the computer or the system can only is good. It can what we call can process in a digital form. So that's why based on the original the original image that you capture, so you need to store your data in terms in digital form in your system. And then after that, there are the second stage where is the data processing. Data processing meaning that when you are given a circuit, the input images. So from the images, you need to pre-process the image. Pre-process the image meaning that you need to make, as I mentioned to you, when the first time you as a human look at any image, so you will define, okay, this is a good image, the quality is good, or the contrast is not good. And then there are many what we call noise. There are many unwanted artifacts. Okay, so we have to remove all those noises, and then we have to make sure that the quality is improved, and we also need to make sure that the contrast is enhanced. So this is what we call a data processing. So by having the before you really process the images, you need to make sure that all of the requirements of the good image has been provided to the system. So meaning that whatever the pre-process that you need to do, that's what we call a data pre-processing. You need to remove the unwanted noise. Is there any noises? And then you need to increase the contrast when you have a very blur image, for example. So as well as you need to enhance the quality. So because you only a good quality can provide what we call the system with when you provide the system with a very good quality, then the process of you finding the region that you want to focus on, after that you want to extract all those features, important features, whatever can be done easily and can be done correctly. Okay, as compared then when you keep the image with a very poor contrast or very poor what we call quality, then the featurization will be have a very low accuracy. So that's why before you provide, you need to provide the system with a very good data or very good quality of images. So that's why you need to do the data processing. After that, then we go for the third one, which is data extraction. Data extraction meaning that when you provide the image or the data with a clean data, with a clean images with a very good quality, with a very good contrast, with what we call less effect, less noises effect or whatever. So meaning that this is now the time that you need to do the real process. Meaning that you need to make sure that where are the region of interest, where are the region to be focused, and then after you identify the regions that you want to focus on, after that you need to extract the features. As I mentioned to you, it's based on the expert. Let's say expert want to extract the size, want to extract the color and so on. So you must make sure that you are correctly detect the region of interest. Otherwise, the feature selection will have a low accuracy. After you have all those features from these extract features, so by using the features, you will use the artificial intelligence. Meaning that you want to use the classifier for you to do the classification, to do the decision based on whatever the features extracted from the third stage. If you fail to provide a good features from this stage, your classification will be low accuracy as well. So that's why from one stage to another stage is very important. From one stage to another to make sure that it can provide at the end of the day a final good what we call the output with the final high accuracy and so on. Okay, so these are the major components in artificial intelligence. Okay, now, so as I mentioned to you, this is data acquisition. To be more detailed, so data acquisition, we can capture images from, because I'm now integration between the image processing and also artificial intelligence. So I focus on the images. So images can be acquired and can be captured from many what we call devices. So we have also CCD camera, and then we have the satellite, and then we have X-ray, mobile, microscopic, and so on. So this one, when you have all of these kind of what we call images, you must make sure that they must be converted into what we call the real world, what we call the numeric values, which is in the digital form. Okay, so because the digital form can be manipulated by computer system. So that's why whatever is, but what kind of, it doesn't matter what types of images that you capture. So at the end of the day, you must make sure that they are correctly converted into what we call the digital image. So it's easy for the computer to what we call analyze. That's data acquisition. And for the data pre-processing, after you get the images, so as I mentioned to you, you have to store the data. Okay, and then you have to make sure that you have a capability, the storage, whatever it is from your system are enough in order to store all the data, all the images. And after that, as I mentioned to you, we need to, if there any noise filtering or whatever, you need to filter the noise. Okay, so you need to filter out, you need to remove the noises, you need to remove the unwanted artifacts in order for you to have only the images with the foreground and the background without the effect from what we call the unwantedness or unwanted artifact. Okay, so after that, this is the example of noise filtering. So if you refer to this one, it is the image which is what we call affected by unwanted noise. So if you refer to this one, it's hard for us to reach whatever the continental here. Yeah, we can read, but the thing is now when you put this one, into a system, so the system basically they will have a problem to read whatever the signage here. So it's continental, right? But when you remove the noise, then it's easy. What we call to look or to write to read whatever the signage there. So so meaning that, so we want to make sure that there are no noise. So in order for us to provide a better images with low effect by unwanted noise. Okay, after you do the noise filtering, we still in the data processing. So you need to make sure that there are regions definition. Okay, now when you are referring to the image capture by any humans, okay, then there might be a problem. Some part of the image we have the underexposed region, meaning that is a very low light in that region. So at the end of the day, when you have a low light, then we will have the underexposure region. And maybe some regions are okay because they have what we call the enough what we call enough and appropriate what we call light. So meaning that we refer is to the well exposed, where the details can be observed clearly. There is no the contrast is okay. So this is what we call the well exposed. And the other one is overexposed, when we have what we call over amount of lightning and so on. So in that case, so the problem is now the common they what we call apply the region definition. They directly apply the image enhancement. The problem is when you have one image with a non-uniform emission, there is a part of dark region, there is a part of the very bright region, and the regions with a very well exposure of the region. So when you apply the image processing contrast enhancement, when you apply the contrast enhancement to the whole image, what happens is you will enhance what we call the region with the underexposed. But what happened to the overexposed? It will become more exposed because you also enhance the overexposed. So there's a problem with the current image enhancement because they do not do a region determination. They do not what we call identify where are the underexposed, where are the well exposed, and where are the overexposed. And then because of that, when they provide or apply the quota enhancement, they can enhance the underexposed because the dark one can be brighter, but the overbright will be over brighter. Okay, so that will give you a more problems after you get the resulting image. Okay, so that's why it is important for us actually to determine the types of the region, either they are underexposed, well or overexposed. Then when after we do this determination, so we will apply a different contour enhancement to the under, to the well, and also to overexposed. Meaning that the underexposed we will have a specific contour enhancement where it will enhance more as compared to well exposure or overexposure region. So meaning that we make that the balance up, meaning that we totally enhance the under, but either we do not enhance or we just give a very small enhancement level to the well and also the over. Okay? So after that, when we determine the region, now for us to apply the image contour enhancement to all of these three regions. So as I mentioned to you, we will have a different contour enhancement for the under, well, and also overexposure region. So it's better if we have one when we pertain it to all of those regions. And then what is actually what is the objective of the enhancement? We need to highlight the details, okay? Because the detail is actually we need the details because from the detail we will extract the features, the important features. Because if we fail to highlight the details, so we will fail to extract the important details. So at the end of the day, the decision will be fail to do a good decision. Okay, so we want to preserve the structure, okay, and also the texture because in medical images, texture is very important because for the normal cell abnormal cell, there will be a different texture. Where the normal cell will be the state is more smooth, while for the what we call for the abnormal, they will be more granule and so on. So the texture, we need to make sure that when we enhance, we are not what we call corrupting all those information. We still need to enhance the most important features as well. Okay, and then after that, after we enhance. We provide the good image with a good quality and good enhancement. So now we need to segment. Segment is actually we want to make sure that we want to focus on only the specific region, the regions that you want to focus. So we call it a region of interest. So the segmentation only can be done if you are with the machine is provided by a good image. If the machine or the system is provided with a very poor image, so the segmentation will be failed. Okay, so these all are in the data processing. So for example, so this is the region determination. So for this one, we can see that the red one is actually for the overexposed. And for the blue one is the underexposed. We can see that this is more dark, this is more, so we cannot see the details here, we cannot see the details here. And the others, the green one is actually the what we call the well. So meaning that we can see the details clearly. So we can see the grass, we can see the leaves or whatever. But now we cannot see the grass here. Yeah, so this is under, we cannot see the leaf here. So it's become black and dark or whatever. So this is what we call the region determination. So by determining this region, so we will apply only the good enhancement or the level of enhancement is more than for the blue region. While for the green region, maybe there are no enhancement, and for the overexposed, which is the green one, we reduce what we call we enhance, but we try to reduce what we call the brightness. So when we reduce brightness, it becomes more balanced, and then at the end of the day, all of this region will be a more balanced in terms of brightness and contrast. Okay, so this is the example when image processing. So if you refer to this one, so this is the what we call the images, the original, and this is the enhanced one. So we can see that this is better. What we call is visually is visually is clearer as compared to me. So similar to the underwater images. So this is the underwater images captured by what we call the underwater camera. So by using the image processing, then we enhance the contrast, we enhance the what we call remove the all those the greenish color whatever. So this is what we get. Okay, so we can see that there is no greenish effect. Okay, so what we see is only the what we call the what we call the items and also the it's no more by the greenness. So we can see the real color of the image for the color for the fish, for the coral and so on. Okay, so this is actually the pre-processing, and this is the region of interest. So the region of interest is you refer to this one. So from here you can see that we try to have this is the nucleus of the cervical cells. Cervical cells is from the human. So doctor use this one to identify either the what we call the woman have the cervical cancer or not. So what they did is they try to what we call analyze the cell or the nucleus of the cervical cell. So if you refer to this one, we cannot see that the edges is blurred. The real edges, the sharpness of the edges is not clear. So when we do the image enhancement, pre-processing, whatever, and we do the segmentation, so we can see that the edges is clearer. Okay, so similar to this one, we can see that there is actually we call it the chromatin here. This is chromatin, whatever chromatin. So we need to have this chromatin because chromatin is one of the regions that determine either the cell is normal or not. So we need to have the ROI segmentation. So we can highlight only the chromatin, the existence of the chromatin in that cervical cell nucleus. Okay, so this is example of the ROI segmentation. So after that, as I mentioned to you, when you are given a good image, so now you go to the real process where you want to what we call extract the features. You extract the features, so we need to identify the significant features or the important features as the input images, and we use the same features used by the humans because at the end of the day, so the system is to be used by that particular what we call stakeholder. If the stakeholder is what we call the engineer, so we need to make sure that what are the features used by engineer in order to detect the defect. If you want to provide the system to the doctor, so we must make sure that what are the features used by a doctor to do the decision when he or she looks at what we call the images. So we need to use the same features, and then after we use the same features, whatever the algorithm is, we must make sure that we extract all those features. Okay, so because the features is actually to be used in our classification process. And before we go for the classification process, which is the first stage, the final stage, so we must make sure that we have to apply the feature selection. The feature selection that when you extract all the features, you must what we call do the next step where you need to identify is it the real features that you need, is it the real significant features to be used. So you need to identify which are significant and which are not insignificant. So when you have a significant versus the insignificant, so at the end of the day, when you use a feature selection, you will remove the insignificant ones. Because when you use these insignificant features to your classification process, it will disturb the classification process. So meaning that before you put it into the classification process, so you must identify here the significant as well as the insignificant features. Only the significant features will be used and will be fit to your classification process. Okay, so you need also to identify is there any missing data or is there any incomplete data or features. Meaning that maybe in one cell you need to extract the size, the color, the texture. Maybe when you have the one cell is only can extract the size and also the texture. You cannot extract the color, whatever. So you must make sure also. Okay, so to identify the missing and incomplete data. Okay, now after you get all those features, whatever. So now this is the time for you to use a machine learning to do the classification. So in my case, because I'm moving towards the intelligent system for the classification, so I'm using I try to use different types of artificial intelligence in order to do the classification. I use support vector machine, I use a fuzzy system, I use a genetic algorithm, particle swap optimization, artificial neural network, and so on. So all of these machines actually they learn from the experience. So you need to train all those machines first with you provide the data, the input data and also the output. So you learn them all of this what we call classifier in order for them to come out with the optimum structure or architecture. When they have the optimal architecture or structure, then then that become a complete system. Then whatever is after that, when you put what we call a new data, so the classifier can do the classification. So this is all about the machine learning system. So they learn based on experience, they learn based on the whatever they supervise between the input and output. They try to map between the input and output, so they adjust themselves, they adjust their architecture, they adjust their what we call characteristic in order for at the end of the day, so they can represent the whole set of input and output data sets. Okay, so the input is actually from what we call the data extracted from the image processing stage. Okay, I give you the example. So this is one of the example that it is done by my PhD students. She has graduated and now she has become a lecturer in another university in Malaysia. So she's developed the intelligence screening system for cervical cancer. Okay, so meaning that she integrate the image processing and also the artificial intelligence to classify the cell of the human cervix, either the cell is normal or abnormal, to identify either the woman have the cervical cancer or not. Okay, so she used what we call the medical images, which is the cell image taken from the human's cervix, which is this is the okay, I give you the scenario in the cervical cancer in Malaysia. So in Malaysia, cervical cancer is actually the second most common cancer in Malaysia after, if I'm not mistaken, it's breast cancer. Okay, so nowadays the cervical cancer become what we call less because we have what we call the new techniques in clinical whatever to what we call to detect the early stage of the cervical cancer. So, but for this one, actually it's done 2 or 3 years before. So now the cervical cancer is become more stable in Malaysia because there are more new techniques to we call. But now we refer to the whole process by a doctor where they put. So if you refer to this one, this is actually the glass side. Okay, so they take the scrap, what we call the cell from the human, the woman's cervix. Okay, they put a spatula inside the vagina of the woman, and they spread what we call a little amount of cell from the woman, what we call cervix, and then they smear on the slides. Okay, on the slide, and then after that they put the slides under the microscope and they observe what we call the is there any abnormality of the cells of the cervical cell. Okay, so this is a data acquisition, how we take what we call acquire the what we call the cell. So this is actually the microscope. Okay, so this is what we call the slide they taken from the human, from the woman cervix. The cell is here. So we have the camera here. So we adjust the magnification, whatever. So the computer will capture the image of the woman cell. Okay. So the problem is when the sample is taken from the human vagina, the cervix. So they are blood. Okay, some they have a blood, they have a vaginal discharge, and also they have the air artifacts, what we call on the slides, together with the cell. So these are the unwanted artifacts that we want to remove from our slide, from our image. And the second limitation is because of the non-uniform illumination. You can see that we use what we call the light from the microscope, and we can see that at the center of the microscope we can clearly see the image, but at the right hand side, upper hand side, bottoms, and also left hand side, the image become darker, darker, and darker. So that's what we call a non-uniform illumination. So meaning that at the darker sides, we need to enhance the what we call the images. Okay, so this is data acquisition. So we capture from the image, okay, using a CCD camera, and then we store it in our computer. Okay. Now this is the enhancement of the TPLAT. As I mentioned to you, the image is actually not good because they are observed by what we call unwanted artifact, and also they are non-uniform, where they have underwhelmed and also overexposed region. So meaning that we need to apply different enhancements. So this is what we try to represent. So we have a different what we call region 1, region 2, region 3, whatever. Then by having these different regions, so we do the histogram equalization. So we increase this region differently, separately. So at the end of the day, we have a very better what we call quality and better contrast images. So for example, so we can see that this is more blur. So when we have the images with our techniques, whatever, so we can have a better images. We can see the chromatin, we can see the texture, we can see the edges clearer as compared to this one. So this is a normal cell, this is abnormal nucleus. So we can see that we can have a better what we call the edges, because the edges is one of the very important characteristic. I will share with you after this. Okay. After that, we need to segment the significant cervical cell. So when you are given the group of cells, so in one images they are a group of cells. So you need to make sure that you only focus on the nucleus of the cell. So they are different nucleus cells. So you need to make sure that you segment out. Okay, this is the nucleus for the first cell. This is the nucleus for the second cell. This is the nucleus for the third cell, and so on. So because why? Because we need to extract the size of the nucleus, we need to extract the size of cytoplasm, the color, and also we need to what we call identify the age irregularity, because because the age also very important, because when we have a smooth age, it is referred to the normal cell. When we have the irregular age, so it refers to the abnormal cell. So chromatin also have what we call the chromatin, the texture inside the what we call the nucleus is also very important. So that's why we need to make sure that you have a capability, your machine have capability to identify the ages and also identify the chromatin. Okay, so this is what has been done. So this is the detection of the nucleus ages. So we can see that from here, visually we cannot see the difference of the ages between normal, low grade, and high grade. This is low normal. This is the abnormal. This is the low grade abnormal. This is the high grade abnormal. It's become the cancer now. Okay, so we can see that normally, visually, by human, we cannot see the ages. But now, when we do what the emergency, we can see that there are different. The ages different between normal, low grade, and also high level, the high grade. Okay, so that's why IP is very important in order to help the humans to provide the better images, better segmentation of ages, and so on. Okay, we can see the difference now. Okay, so this is the chromatin region. So if you refer to this one, this is normal, this is low grade, high grade. You cannot see the distribution of the chromatin. This is the chromatin. Okay, so this is the what we call chromatin is one the terms, medical terms. So chromatin. Okay, so we cannot see the chromatin. But now when you have what we call on the segmentation of chromatin region, you can see that the difference between the normal, the low grade, and also the high grades. So that's why maybe doctors have the experience, so they can see, oh, this is a very crowded chromatin, but this is not a very crowded, so this is abnormal, this is normal, whatever. But now as maybe for the new doctors, so it is difficult for them, okay, to identify where actually the chromatin inside the normal, inside the low grade, and also inside the high grade. So by providing the image processing, so it helps the new, especially the new doctors or the new experts, whatever, to And you, yeah, it's correct. This shows the chromatin. So now I know where are the chromatids there. Okay, where are the chromatids? So this is what I report and so on. So this can provide access the new the new wishes whatever in order to do a better diagnosis at the end of the day. Okay, so that's what we call the image processing help the student assist the what we call assist the user. Okay. Now, this is the affection of the irregular. So, meaning that we, after we find the what we call the edges, so now we want to differentiate between the how to what we call digitally. We want to differentiate between the normal age, the low grade age, and also the high grade age. Okay, so when we have so this is one of the exception that we propose. So if I want to discuss with that, this will be a long one. So basically, this is one how we extract the irregular features. So at the end of the day, we can see that by using our techniques and also the other technique, this is the conventional technique. This is our technique. We can see that our techniques can differentiate between normal and low grade, between normal and high grade, and also between low grade and high grade. Okay, so that's why when you are given one image, so you make sure that you properly done and they can do whatever the image can do to differentiate between one class to another class. Okay, and then similar to the expression of the chromatin. So when if you refer back to my previous slide with the blue one, the blue region, so that's referred to the what we call chromatin. So from the chromatin, we can extract all of these characteristic: chromatin number, area of chromatin, total chromatin area, and so on. So we can see that there is a difference between the normal, low grade, and high grade. This table once again can help doctors to in order for them to do a diagnosis. Okay. So at the end of the day, so we have our own by use the chromatin size and chromatin distribution, whatever, so we can have our suggested table for the doctor. Okay, then we compare with the what we call the system, the previous system, which is the pesticide system and also the VSCC. These two are the common what we call system by doctors nowadays. So we have our own. Okay, so we compare with this pesticide and also VSCC technology. So we can see that there is actually the similarity between our suggestion and the VSCC. Okay, so this is only based on the image processing. So at the end of the day, when you provide these tables to the doctors, so they can use the doctors as a guidance for them to do the final diagnosis. Okay, and at the end of the day, we use the classification of by using all those images extracted from the image processing stages. So now we feed them to our intelligent classifier. So we try to use the ANN, we use the CVM, support spectrometry, fuzzy and so on. But in our case, we use the artificial neural network, which is MLP, multi-layer perceptron, and this is what we get. So the accuracy is 95%. 95% of the tested what we call cell is correctly detected by our system. So this is actually how we want to combine between the image processing and also artificial intelligence, combine together to develop a complete system. So we must start with a very basic one. How do you acquire the image? And then when you get the image, you need to identify the characteristic of the image and try to eliminate all the problem occurs in that image. And after that, you by using the extraction, whatever, you need to extract the important, the significant features from the image before you feed that features into our classification in order to do the classification. So that's actually the whole process of the how we develop the intelligence system by integrating between image processing and also artificial intelligence. So I think that's all for my presentation today. So I give back to what we call to the MCs. Okay. So is there any question? Then you can ask me. Okay.
Yeah. Any participant would like to ask any question? Please unmute yourself. Please ask questions to Professor. He's ready to give you answer. Okay, Professor. Meanwhile, it's an excellent presentation. I have one question.
Okay.
Now we are discussing
I know it's not a difficult one.
It's not a difficult one.
Okay.
Excellent presentation. Today, human versus machine, very good. I have one question. How much efficiency can we expect?
Okay. Okay. Now, once again, it depends on the what we call a stakeholder. When you refer to if you want to have the system for the medical purposes, then it should reach 100%. Of course, because we play with the human life, right? So the what we call the accuracy must nearly almost 100%. But if you refer to the what we call the engineers, whatever, so if you can provide a better solution, which is when you what we call test the accuracy of that system, it might be higher than the accuracy by the human before you provide the system. So if you can have a better accuracy as compared to the what we call the humans what we call accuracy, then it should be okay. Okay, that's for me for the what we call the part. If you can what we call above the part, then it should be okay. But once again, it depends on the stakeholder. It depends. That's why the most important thing when you want to develop a system, you need you must get the what we call the information and also the requirement from the stakeholder, because you need to fulfill the requirement. So I cannot say that how many percentage is to be good or whatever, because some cases it's very difficult to do the analysis. Some case is quite easy, because I think whoever or researcher play with the data, so some data is actually easy to be classified. Some data is very difficult to be classified. So once again, it depends on the stakeholder. If the user want, okay, this is good enough, 80% is good enough, 90% is bad, so you might make sure that your system can achieve that what we call requirement from the stakeholder.
Yeah.
Okay.
So over to participants. Anybody would like to ask question, you can ask. Professor is ready right now.
Yes, Professor, we have a question asked by one of our participants. So, Mr. Ramaraju Devaraju has asked a question. Can you give the reference of the article on cervical cancer?
What is?
Cervical cancer.
Okay.
He wants the reference of the article on cervical cancer.
Oh, what article? About the journal.
Professor, can you go?
Okay, the reference. Okay, basically when you Google my name in the Google Scholar, I think you can have all of my what I call my article is actually you can download from there. If you have the problem, then you can email me.
Yeah, it is there. It is there in the Google Scholar. All your articles are there.
Yeah.
So participants, if you have any other questions, you can unmute yourself and ask your questions to the professor. Feel free to unmute and clear your queries.
Yeah. Meanwhile, I have one more question, Professor.
Okay.
Shall I ask you? Yeah. What are the present research applications? I mean, research going on medical field.
Okay. Okay. To be frank with you, basically, many researchers, they are not going to focus on the medical application because it's very difficult to get the data. Because now the data is very difficult to get the data. So for my case, for the cervical cancer, I have to wait. I have to collect the data for maybe 3 to 5 years in order to get enough data to train my system. So that's the main issue in the medical field, because because you know that the medical they have an ethical approval because it's we play with humans life whatever, so there are ethical many process. So that's why to get the data is actually very difficult. To be fair with you, yeah, there is not much what we call researcher focus on the medical application.
Yeah. What are the other areas they are focusing right now?
I think they are more focusing on the, you should refer to the electronic, also the electrical for the hotspots. You know the hotspots when we try to check the, you know, the electrical wiring to check the hotspot of the, where are the hotspots, maybe they want to have a short circuit and so on. So they use the image processing to, by using the infrared images, so they can see that they can have the electrical appliances, electronic appliances. They can have the green region, the yellow region, and also the red region, right? The red region is very dangerous. So from there, they extract the information and they do the classification. Either it is should be replaced or not. So and then they also have we also have in terms of biology, which is we try to identify the cleanness of the water. Okay, the quality of the water, river water in Malaysia. Sometimes the river water in Malaysia is also very pollution now. It's polluted now. So we use the what we call we take the water from the river, and then the similar way we observe under the microscope, we capture the image, and then we try to identify the microbe inside the water, and based on the types of the microbe in the water, we classify either the water is clean or dirty and so on. There are many, actually, when you have the intelligence system, it can be applied to any area, because we are use the same process where we have the image processing, then we have the classifier. So when you have the images, so basically when you have the images, then you can do the image processing to extract what we call the significant features. Then after that, you do the image processing, the artificial intelligence to do the classification. So it's that way can be done.
Yes.
Okay.
Any more question? One last question.
So, Professor, I would like to ask you a small question. What would be your advice?
Okay, no problem.
What would be your advice for the people who are just starting their interest, just stepping into image processing? What would be your advice for them?
Okay. Basically, I want to. Okay, this is my experience. So during my PhD, actually, I focused on image artificial intelligence, which is a computational intelligence. Then when my supervisor gave me the image to classify the image, which is the cervical image. Actually, I also my PhD in cervical image. So when I look at the image, I think I cannot what we call straight away classify the image, because there is so much what we call processes can be done to the image. It's very interesting because, you know, when it seems that you look at something, then you want to make sure that when you look very but that the quality is there, the contrast is there. You need to make sure that you can clearly observe any regions or whatever. You need to see the beauty of the image. Visual, right? So when you have the human visual, so how do you want to imitate to transform? You see the image at the computer. You want the computer to do the same as what you want to try to do. So that's very, very, for me, it's very, very, so you must have the interest in terms of the university. And when you want to start with the university, what you have to do is you need to process, you go to the pre-processing first. You want to make sure that, okay, you provide the good image to everybody, to the user. So for me, when you can provide the image and you see, oh, pleasant, it's a very pleasant image or to visualize or whatever. So I think the interest will be developed further and further. So that's mine, you know.
Yes.
Is that Dr. Shanti? Could you just
Yes.
Yeah.
Yes, correct. Yeah, it was an excellent session. So
Okay.
it's a time for ending the session. Ladies and
Okay.
gentlemen, a very warm and pleasant good afternoon to all. At the outset, it gives me an immense pleasure to propose the word of thanks for this wonderful occasion, international webinar on integration of image processing and artificial intelligence for intelligent system development. I would like to thank today's resource person, Dr. Noor Ashidi Mat Isa, Professor, School of Electrical and Electronic Engineering, Campus, University Sains Malaysia, Penang, Malaysia, who honored this program despite his busy schedule, has found time to grace us with his wonderful lecture. Terima kasih.
Sama-sama, thank you. It's Vanakkam, right? It's
Yes.
Vanakkam?
Namaskaram.
Namaskar.
Yes, thank you. I also express my sincere gratitude to Thickness Learning Community, young and dynamic founder, Mr. Kritik Raja, for his backing and arrangement to make this webinar grand success. I'm also very grateful to Thickness Learning Community members for their encouragement, valuable contribution, wonderful support, because we have received more than 100 plus registrations from various states of India and different parts of the world. Not the least, I would like to thank all Thickness community beloved participants from various states and international participants also for showing their interest in this webinar, for making this event as a resounding success. Thickness Learning Community upcoming webinars are Internet of Things, Cyber Security, Mobile App Development, PCB Design, etc. Once again, I thank and all present here. Thank you very much.
Thank you.